Welcome to Free Code Camp. I'm Commander Candy of Coding Commanders, and today I'm going to teach you all about logic. Logic is the foundation for all computer programming, so the better you're able to understand logic, the better and faster you're going to be able to pick up and learn any programming language or encounter any programming endeavor. Introduction to Logic for Programmers, Propositional Logic. You'll find reference materials and homework at codingcommanders.com/logic.php. Mathematics, science, and computer programming all are based on logical reasoning. What logic does is it defines a set of rules. If we want to be able to scientifically or exactly determine something, we need rules defined to make sure we're all measuring by the same standards, to make sure that if I say this is a cup means the same thing to you that it means to me. And at the end of the day, we use logic to determine whether things are valid or invalid, true or false. If you're going to be doing computer programming, especially if you plan on doing business logic, building enterprise applications, working for a company, it's a lot of validation, a lot of true or false, especially on the back end. I've worked with like PHP, Node.js, SQL, and a lot of what I do when I'm hired by somebody is validation. Is this valid or isn't this? Is it true or is it false? If you really think about it, at the end of the day, just about anything can be boiled down to true or false. For example, say you're taking a multiple choice test and the question is 4 plus 4. It's multiple choice. Your options are 2, 4, 6, 8. Now we're smart mathematicians. We know 4 plus 4 equals 8, right? But even though that's open-ended, that's not a true-false question, we could break the problem down to 4 true or false questions, right? Does 4 plus 4 equal 2? False. Does 4 plus 4 equal 4? False. Does 4 plus 4 equal 6? False. Does 4 plus 4 equal 8? True. And because that's true, that's what we're going to select as our answer. Today we're going to cover propositional logic. That's the basic building block of logic. It's a way for us to determine whether things are valid or invalid. You may also hear it referred to as statement logic, because you could basically think of a proposition as a statement. For example, I have blonde and red hair today. That statement is true. Propositional logic allows us to evaluate whether things are true or false based on certain conditions. Does this sound familiar? In computer programming, if statements are directly derived from propositional logic. And in this video, we're going to learn how. Remember, logic is all about defined rules. So first things first, let's properly define a proposition. A proposition is a statement. It has a truth value. That means it's either true or false. It's not equal to jelly beans. It's not equal to 564. It's going to be true or false. And a proposition can only have one single truth value. So it can't be true or false. It has to be either true or false. So let's look at some statements and determine if they're propositions or not. The first one, Commander Candy is 4'11". Is that a statement? Yes. Does it evaluate true or false? Yes. And it can only have one single value. I'm either 4'11" or I'm not 4'11". So yay! Commander Candy is 4'11" is a proposition. By the way, this statement is true. Commander Candy is a halfling. I'm 4'11". What is your favorite flavor? Is that a statement? Yes. Does it evaluate true or false? No. This is not a proposition. Whatever your flavor might be, chocolate, vanilla, strawberry, mocha, banana, mango, it's not true or false. Next, x plus y equals 36. Is that a statement? Yes. Does it evaluate true or false? Yes. Either x plus y is 36 or x plus y isn't 36. but it doesn't have a single value. Depending on the values of x and y, it could be true or false. So, this is not a proposition. The better you are at logic, the better you're going to be at breaking down those complicated problems that we encounter as programmers. If you can get it broken down to its basic building blocks, is this true or false? Is this true or false? You can solve just about any problem there is. We can combine propositions in order to solve more complicated problems. In order to do so, we're going to use variables such as p, q, r, s, x, y, z. We're going to use logical operators, things like and or. We're going to learn some others. And we're also going to use comparison operators like less than, greater than, equal to, not equal to, less than or equal to. We'll go over some of those as well. Now let's talk notation. Okay, let's look at an example. We're going to start with two statements, P and Q. Let's let P equal Sally is 42, and we'll let Q equal Linda is 36. Now let's look at some ways to compare these two statements, P and Q. We can do P and Q, we can do P or Q. There's also comparisons like exclusive, implication, biconditional. In order to evaluate if these statements are true or false, we're going to use something called a truth table. Truth tables consist of multiple columns. There's going to be a column for each statement or variable, and then there's going to be a column for what we're trying to evaluate. In a scenario like this, where we have two statements or two variables, there's going to be four possibilities. If Sally is 42, Linda can either be 36 or not be 36. So if P's true, Q can be true or false. And if P's false, Q can be true or false as well. If Sally isn't 42, Linda can still be or not be 36. So let's first look at and. Sally is 42 and Linda is 36. So that means both those statements are true. Both P is true and Q is true. So there's only one possibility that will make the statement true, and that's if P's true and Q's true. If there's any false going on there, the whole thing is going to evaluate as false. Next, we have or. Sally is 42 or Linda is 36. With or, P and Q, they don't both have to be true. Just one of them has to be true. If just one of them is true, then the statement P or Q is going to be true. With or, they don't both have to be true. Just one has to be true. So Sally can be 42 or Linda can be 36. P or Q. So if there's any truth going on here, the statement's going to evaluate as true. If Sally's 42, it's going to be true. If Linda's 36, it's going to be true. But they don't both have to be telling the truth. So there's going to be three possibilities of truth here. The only way that P or Q is going to evaluate false is if both P and Q are false. Next, let's talk about exclusive. That means P can be true, Q can be true, but they can't both be true. So if Sally is 42, it's going to evaluate true. If Linda is 36, it's going to evaluate true. But if Sally's 42 and Linda's 36, it's not going to evaluate true. If Sally isn't 42 and Linda isn't 36, it's not going to evaluate true. You need exactly one true and one false. There's going to be two scenarios to evaluate as true. Now let's look at implication. Implication is going to read if P, then Q. P is what we call the hypothesis, and Q is the conclusion. This is a conditional statement, like our if statements in computer programming. Those are implication. So let's look at implication. If Sally is 42, then Linda is 36. If Sally's telling the truth and Linda are telling the truth, then the statement's true. If Sally's telling the truth and Linda's lying, then the statement is false. If Sally is lying, then it doesn't really matter if Linda telling the truth or lying. It could still be true because it has nothing to do with Linda at that point. There's only a condition applied here if Sally is 42. If Sally lied, then, it doesn't really matter anymore anyway. Now let's look at biconditional. That reads P if and only if Q. Another way to write that is the if with two F's. And this statement is going to have the same truth value as P implies Q and Q implies P, saying it goes in both directions. So basically, if Sally is telling the truth and Linda's telling the truth, this is going to evaluate true. If they're both lying, it's still going to evaluate true. But if one's telling the truth and one's lying, no matter which direction it's going in, it's still going to evaluate false. And now let's just touch on negation. Negation, you might see it written in any of these ways, like -6, that's negating 6. It's the opposite. Not. It means like not P. That's how you would read that. Or the opposite of P. So basically, if P is true, not P is going to be false. If P is false, not P is going to be true. Now we're going to look at some of our comparison operators: less than, greater than, less than or equal to, greater than or equal to, not equal to. These are some comparisons. There's also like identical, if you're familiar in computer programming, like you have like the 3 equal signs. These are comparison operators. These are ways that we can compare numbers, and we use these often in our conditional statements. Okay, let's go ahead and take it back. We're going to bring it back to computer programming. I'm going to show you some examples of conditional statements in a couple programming language and how this relates. And trust me, as the computer code you're writing gets more complicated, a good, firm, solid understanding of these logic fundamentals are really going to play a big part on your ability to be on your competency. My next video, I'm going to do set theory. That's another very important concept. It's like the next step in logic. If you understand propositional logic and set theory like really, really well, you are going to excel at learning whatever programming language or techniques you're trying to learn. Let's look at an example. Your friend invites you to dinner. You are only interested in going if dinner is at a Greek restaurant. Write your response using implication. Now remember implication, if P, then Q. If not P, then not Q. Okay, let's break down this example, okay? So your friend invites you to dinner. That's not really important. You are only interested in going. You're going to go if dinner is at a Greek restaurant, right? You're not going to go if it's not at a Greek restaurant. If dinner is Greek, you are going to go. If dinner is not Greek, you're not going to go. The hypothesis is dinner is Greek. That's the P. And the conclusion is I will come to dinner. You're writing your response. So if dinner is Greek, your response is going to be I will come to dinner. Let P equal Greek. Let Q equal I will come. Let R equal I will not come. If P, then Q. And if not P, then R. And here I use this example from my website because it already has the rules for a conditional statement clearly written out. So I'm going to explain now how we're going to transfer that into computer code, okay? So this example is in PHP. I'm also going to show you with JavaScript afterwards. the way the syntax works in PHP for if statements, you write if, inside the parentheses your condition, and then inside the brackets whatever code you want to execute if the condition is true. And it's the same construct in JavaScript. It's pretty common here. This is where things get a little bit different than JavaScript, but I'm going to show you how it's easy once you know the base logic to write it in whatever language. If $dinner equals, or you could put 3 equals there, Greek, echo, in PHP echo prints something, yes, I will go to dinner. Okay, so now we are going to write this in PHP. We're going to let P equal Greek, Q equal I will come to dinner, and R equal I will not come to dinner. So if P, then Q, and if not P, then R. So how would we write this in PHP? $P equals Greek. In PHP, this is how you declare a variable. You put a $sign in front of it, and then you know it's a variable. So $P equals Greek. I put Greek in quotes because in PHP, a string, that's like words, sentences, characters, we put them in quotes, double or single. Then I have $Q equals I will come. We're ending each line with a semicolon because that's how you do it. $R equals I will not come. So basically the condition is your P, and then inside is your Q. If dinner equals Greek, echo, I will come. Else, what else means is it's the opposite of whatever condition is in here. So if in here I wrote x equals 3, if x equals 3, this would execute. And if x didn't equal 3, this would execute. So else, echo, I will not come. See how this could be simply translated into whatever programming languages you're at. You would have to Google how do I declare a variable, what the syntax looks like. But once you get the construct, the condition is the P and the code is the Q. Now let's take a look at it in JavaScript. In JavaScript, instead of putting a $sign, we just name them whatever we want, and then we put bar in front of it. So, and other than that, it's pretty much the same as with the PHP. In JavaScript, we can print to the terminal using console log. So instead of echo, I use console log here. But those are the basic differences, as you can see in the syntax. Bar instead of $sign, console log instead of echo. Other than that, we're transferring it the same way. We put our P in here, and we put our Q in there. Don't forget, I do have homework in the form of a quiz game and some reference materials available at codingcommanders.com/logic.php. On that page, you'll see links to everything I have related to here to help you out. Now let's do some practice problems together. Now I'm just going to do some simple little math problems with you using logic, so you can get a better grasp on how to apply the logic to real life problems. I definitely suggest afterwards checking out the quiz I have to reinforce the logic that you've learned and also get better at it, quicker at it, sharper at it. Good idea would be to these examples that I'm doing, go ahead and write it out in whatever programming language you might be working on, if you've started learning one or if you know you want to learn one. I did also link materials on writing logic in PHP, so if you're not already working on a programming language, go ahead, write out my examples in PHP. If you can't think of how, you can always console log print equals. I have this like blown up a little bit. It looks a little pixelized, but it's cool, right? Pixels are cool, right? So let's do x equals 2, and we're going to go ahead and do y equals 0. So let's say that x equals 2 is our p, and y equals 0 is our q. P and q would mean that x equals 2 and y equals 0. So let's say if x plus y equals 4. What are the truth possibilities here, okay? So let's see, what are the different possibilities of truth here? First of all, okay, if x equals 2 and y equals 0, 2 plus 0 is 2, not 4. So something's fishy here, right? Would it be possible for x and y to both be true? Would that be possible? No, this one would be false. Would it be possible for x or y to be true? Yes, this is possible. We don't have enough information really to know anything. You know, we know that one of them's lying at least, right? One of them could be lying or both of them could be lying. So here, this could be true or false. We're going to need some more information here to make a definite decision. But if I were to give this to you as a given, this could still be true. Now let's do XOR. Could be true or false as well, right? Okay, now let's do this. I'm going to give you some information and let's come up with some stuff that's true and some stuff that's false. Given x is less than y, that in parentheses, and x equals 3. So we're going to take this as fact. Now let's see. I'm going to give you some values and you tell me if it's true or false. Y equals 3. Y equals 0. Say y equals 3 times x. Okay, now you tell me what's true and what's false, okay? First of all, with the given, it's an and, so that means both have to be satisfied. X has to be less than y, and x also has to equal 3. So which of these statements could be true given the information? Okay, if x is less than y and x is equal to 3, can y also be equal to 3? No. If it was less than or equal to, that could be true, but it's not. So this is false. But extra that. We know that's definitely not the case. Y equals 0. If x equals 3 and y is less than x, could y be 0? No, because 0 is less than 3. And y's got to be bigger than 3. False. Y equals 3x. Could y be equal to the value of x times 3, which is 9? Yes, because 9 is bigger than 3. Okay, given, I'm going to give you some information, and this information I'm giving you, we're going to just assume is true. X equals -3, y equals 3, and z equals 0. Now, I'm going to give you some statements, and then you tell me if they are true or not. Let's do -y is less than 0. X is equal to y. And x plus y equals z. All right. -y is less than 0. Okay, y is 3. Y is 3, so -y would be -3, and -3 is definitely, this is so true. Yay! Oh, I spelled true wrong. Okay, I'm going to give it a star. Now let's do x equals y. If x is -3 and y is 3, those are not equal. So this is false. X plus y equals z. Does -3 plus 3 equal 0? Yes, it does. This is so true. Yay! Thank you for watching my video. If you have any questions at all, please don't hesitate to comment below so I can help you out. I will be going through the comments on this video. Also, feel free to reach out to me on any of my social media, at Coding Commander on Twitter. Everywhere else, I'm Coding Commanders. You can just Google me, see where I'm at. Thank you again for watching, and until next time, happy coding.